When Henry Ford proclaimed, "I will build a car for the great multitude," not even he realized how great that multitude would be, or just how much asphalt, congestion, and carbon dioxide would be created from his vision. Our obsession with the automobile, while still a symbol of independence, just might show us how dependent we really are.
The average American drives 1,000 miles a month, 12,000 miles a year, the distance to the moon every 20 years. You know, if you had to distill the American ethos into a single product, it would undoubtedly be the car. But the bigger point is that Americans consume 3 gallons of gasoline a day, their own weight in gasoline every 7 days.
Some people that look at the question of energy and cars say the problem is America's obsession with the automobile. SUVs are the work of the devil. Well, I say that actually gets the problem wrong. What cars represent are actually good things: freedom, mobility, independence, personality. This is why people anywhere around the world, whether it's China or Brazil or South Africa, as soon as people can get enough money, they aspire to get into their own cars. There are a lot of good things that come from cars. I say the problem is oil, and cars can be the solution.
You know, the issue of cars and oil really is a global issue. There's 850 million cars and trucks in the world today. And that sounds like a lot, and it is a lot, but with over 6 billion people, that means just 12% of the people in the world own an automobile. Now, we're forecasting that by the year 2020, that global number of automobiles is going to grow to about 1.1 billion. Now, if you take those cars and park them end to end and wrap them around the world, they'll go around 125 times.
Adding to that orbit will soon be hundreds of millions of cars from developing countries. India's Tata Motors plans to launch a $2,500 car next year, leading a trend for other car companies in a race for the masses, many without emission controls. These cars will add untold demand on the world's already precarious oil supply.
Illustrating just how frail our energy infrastructure is in the United States. We had the blackout in the Northeast. We've had Katrina and Rita and issues of nationalizing energy in South America. Add on all of the economic growth that's going on in China and India and elsewhere, and it's just sort of screaming that there is an issue here. There's a very, very significant issue, and the common denominator is petroleum and our dependence on petroleum. And we have to find solutions. We have to find solutions as soon as we possibly can.
In round numbers, a third of our energy goes to buildings, a third to industry, and a third to transportation. The actual numbers differ a bit. What's really important, though, is in the use of oil. Our transportation is about 97% oil-fueled, and about 70% of our oil use fuels transportation. So those are the two sectors that are intimately intertwined.
Good morning, ladies and gentlemen. Welcome to the Nissan display. My name is
The clean car of the future will not burn gasoline in an internal combustion engine. Now, what will it actually burn? It may not burn any fuel at all. It might be hydrogen used in a fuel cell. It could be an electric car. It could be a plug-in hybrid. It could be a flex fuel vehicle that has ethanol, for example, or another kind of biofuel. Right now, there's an explosion of technologies and a marvelous era of innovation in transportation technologies that we haven't seen in 100 years. Let's remember that back at the turn of the 20th century, there were more electric cars on the roads of New York than there were gasoline cars. And Henry Ford's Model T ran on ethanol as well as it ran on gasoline. It was a flex fuel car. So we might really be going back to the future.
Henry Ford would be appalled at how inefficient that future is. In 1908, his Model T got 25 miles per gallon. 100 years later, the average car today gets 21.
A typical car today uses every day 100 times its own weight in ancient plants, inefficiently converted to gasoline. What happens to that fuel energy when it goes in your tank? 7/8 of it gets lost before it gets to the wheels. Only the last 6% of the fuel energy actually accelerates the car and then heats the brakes when you stop. And yet 95% of the mass you're accelerating is the car, not the driver.
Barely 1% of the energy in a gallon of gasoline is used to move the driver in a forward direction. I mean, that's incredibly inefficient, and that's after 100 years, the world's best engineers working on this.
What kind of car will the city of the future see? The monster is trundled out onto the highway to frighten other motorists.
New sources of power are being developed which may eventually bring the gasoline age to an end.
Dream cars of the future have promised many things, even the ability to fly. The first step in getting there is making them weigh less.
I have no question that the future for transportation involves lightweight materials. This has got to be the future, in part because it allows us to have our cake and eat it too. If you have the same car, but it's made from very strong but much lighter materials, you'll use less fuel.
We use carbon composites in military and aerospace where cost is almost no object. But to move into automaking, you need to make these composite structures in 1,000 times higher volume and lower cost than now. And now we actually have ways to do that can make aerospace quality at automotive cost and speed. And that's the revolution I think everybody in the auto industry has been waiting for.
Colorado startup FiberForge is pioneering a new method for mass-producing lightweight carbon fiber.
The FiberForge process is aimed at creating affordable structures that are lighter in weight. This is called long discontinuous carbon fiber. Today's carbon fiber ranges from $10 a pound to $120 a pound, and the cost per pound to process that is also very high. It's on the order of $100 a pound for most commercial processes. And we said, well, what if we just took the $10 per pound fiber and came up with processes that were much more affordable to get it into a finished part? What you see here is the FiberForge automated layup system, and it is essentially a high-speed tape dispenser that dispenses the pre-impregnated thermoplastic tape onto a 2D table. We decided to focus on thermoplastics when we came up with the idea of making products that can be stamped. Most other composites on the market are made with thermoset resins that take two chemical compounds, mix them together, put them into the final shape, and then they need to cure, and the chemical reaction needs to occur. And so that's a challenge to manage from a high-speed throughput. What we use are thermoplastic resins, such as nylon 6, and it's a readily meltable resin that can hold these fibers together and transfer the load from one fiber to another in a finished part like this.
And you end up with an amazingly strong material. This particular one's tougher than titanium and really stiff, as you can tell from the sound. So plastics have changed since the Graduate.
This is a concept vehicle that the company made about 4 years ago. It was a 2-year effort to develop a lightweight hybrid electric vehicle that was about half the weight of today's cars. So it's a 2,000-pound vehicle that would be comparably safe hitting a Ford Explorer as the people in the Ford Explorer.
These materials can absorb 12 times as much crash energy per pound as steel and do so more smoothly, so you use the crush length up to twice as effectively. So safety actually improves when you make the car only half as light as the stuff around it.
This is the composite demonstrator of the left front portion of the vehicle. So this would be the door frame, and it shows how several pieces come together in a pretty complex design, where this is the front firewall of the car, and then this is the A-pillar right behind the driver's side door. And it approximately weighs on the order of 60% less than a steel structure of the same geometry.